Alright, it's March 27th and I have to start somewhere. Basically there's three sections to the game: chassis, tires, and the engine. What we're looking at right here is the engine profile, and I will go over it briefly. All the AI and computer transmission gear ratios do not matter at the moment. This is the number of gears that we have for our engine. Let's say it's a transmission and an engine combination. 6 gears for these guys. Alright, so we have 4 basic physics in the game. NASCAR that they race on Sunday, lower minor league that they race on Saturday. I'm gonna make them orange. CTS trucks that they race on Friday. This would be like the trucks, and the Trans AM series, those are for road racing, and therefore you can see how they have the 6-speed transmission. I'm not gonna go in too much detail, but engine number 2, engine number 7, engine number 12, and engine number 15 are the most used engines in the game. As you can see by the number of chassis that use these engines, these are the most used ones. We also have restrictor plate engines that they race on Talladega and Daytona. Trucks and PTA do not use restrictor plate. And also we have chassis 0, which is a special chassis. You need to select it on your own if you want to play it and race it in the game. Anyway, too much details on this. I'm gonna mark it as green, but I'll tell you why this one is important in a moment. Now let me underline the most used engines in the game right here, and this is what we're dealing with pretty much. This is about 17 values. These two do not really matter, and here we go. Basically what I figured out so far, we have the power section, that's what I call it, that consists of RPM and cylinder pressures. I do not know what kind of cylinder pressures those are. I'm just assuming that these are PSI. I might be wrong at this time, so I'm showing this. It's called torque 1, 2, and 3, but I thought that those are BMEPs, but those could be net MEPs or indicated. Anyway, this is the power section. What also raises questions in my head is why this RPM is set at 0, because we're not producing any horsepower at 0 yet. I guess we could make a bang as early as 4 RPM, 2 RPM. Anyway, then this section right here I call the physical dimensions: the stroke, number of cylinders, and the cylinder displacement. This is basically the physical dimensions of our engine, and these numbers will also help us calculate bore. I'm just gonna put like a green square right here for bore, and bore will also help us calculate the piston area, if I am correct. Then we also have stroke already. Stroke right here. Then we have N as the number of RPMs. Here's our range, 7, 9. You could choose your RPMs right here. And the K is the number of cylinders. So pretty much we have our Planck formula right here. I'll mark it right here in blue as what I see as our Planck calculations so far that I figured. I have no idea how the actual hard code works in the game, but as far this is what we got. Then at this point I assume, this is my personal opinion, that we have to deal with volumetric efficiency of how efficient our engine is moving air, and we have to deal with thermal efficiency of heat and friction and engine overheating and all that stuff. There comes the volumetric efficiency values of what I call is this one: number of intake valves and the intake valve size. Unfortunately, these are the only values that we have. We don't have any valve lift, camshaft profile, none of those. They might be simplified into a simpler formula in the hard code, or they might be included and we just have no access to them. This is another mystery that I have. I don't know anything about the camshaft profile. All we know is how many intake valves we have and what's the size of them. Next thing is a red line, and I'll add it to the power value section. However, it is not really a red line, but rather a rev limiter. Rev limiter. It has nothing to do with the actual limitation of how fast the engine could spin. That has to do with its dimensions and the pressures. This is where it's pretty much gonna cut the spark and fuel. You could choose that. Another mystery is peak power. Changing this value to 0, changing this value to 10,000 doesn't seem to do a damn thing in the game in terms of like the game feel. So I'm really confused on this one as well. It might be some kind of reference number. What else? Really out of ideas on this one. Changing this thing doesn't do anything. So this is why the creator of the program put a question mark right here. I have no idea. And then we have oil and water cooling. I am yet to figure out what the units are. I really don't know what the units of this 450 and 1390 are. I assume it might be the energy that get lost to the fuel, to the cooling system. It might be the rate of transfer from engine to oil, and from oil to water, and from water to air. Really didn't do that much testing on these two. On my testing right now, I run these numbers at 0, assuming we got no oil and no water cooling. I don't know if that's correct or not, but I do that just to see how much initial heat and how fast we introduce right away. Like I could look at the oil temperature, I could see this guy rise, and I could kind of judge how fast it is if I set these numbers at 0, just for testing purposes. So this will conclude my video number 1, the most basic view at these numbers. Power section, engine dimensions, airflow, red line, peak power that doesn't mean anything, and then the cooling. It's not that complicated. I am afraid it is too simple. Like we might need more values to accurately calculate. Maybe something's not included. I'm really not in the know as of this point, but I'll make a part 2 comparing the values between all different engines right now, so to kind of pinpoint my strategies as I go farther on with these numbers. But for now, this would be the part 1, kind of to give you guys an introduction of how the basic engine profile is structured. There you go, just stay tuned for part 2. Okay, and in this part I'm gonna go briefly, as fast as I can, through the differences that kind of catch my eye right away when I try to compare this whole field between each other. Let's say if all the values were the same for every engine, it would be safe to assume that we cannot change anything because we do not see any change present. However, by noticing little differences between different engine profiles, it will give us additional clues to kind of trying to understand how this whole thing might work. First things that I want to mention is the peak power that doesn't seem to matter, yet we could see how Sunday NASCAR makes way more than restricted plate right here at 435 versus 815. So there is kind of difference. So these are different numbers, yet changing them to 0, changing them to 10,000 doesn't seem to work, but they are present. Our engine number 0 for chassis number 0, the special one. Let me briefly jump to that one, and that's cylinder dimensions, cylinder displacements, forgive me, and regular NASCAR all the way through races the 358. That is in the rule book. That's the official rules. You could find the proof of that anywhere. However, chassis 0 uses a big block 450, and this is the biggest and the most important difference that I saw. That means that we could run different displacement engines in the game, that the game has a different displacement engine in it. That gives us hope that we could make a 302 or a 383 somewhere within. We're not sure, but this number right here, chassis 0, this is like the key to unlocking that thought that we could run a different engine in it. To prove it, as you can see, it has a bigger stroke, so we're already dealing with a different drive line, different cylinder dimensions, different stroke. Now I must mention restrictor plate that run with less power, run at the same speed at Daytona and Talladega, about 200 miles an hour in draft, and the difference in stroke, as we could see for those restricted plates, are also noticed at 3.5. And then the rest of the regular NASCAR engines use 3.308, and that's the stroke that they have in order to achieve the 358 cylinder displacement. Number of cylinders is V8. Obviously we're all running V8s all the way through, and this makes me doubt that 6 cylinders and 4 cylinders will work properly, simply because of the camshaft profile thought that I had before, and just in general, you know, but V8s are enough for now. Then the values for the intake valves, they all have old school cylinder heads with one valve. That is fine, which makes me doubt, can we run the 2 valves per head cylinder heads? That's another one for future. Now, intake valve size, they're all at 2.7 regulated by NASCAR. Instead, except our big block 450 right here that has a bigger intake valves at 2.2. Also, the big block 450 has a massive difference in oil cooling. The biggest numbers here we have is 450 and 350 for the less powerful restricted plate engine. This guy runs over 1,000 on this one and close to 2,000 on water, so almost triple the oil and almost double the water for our big block cooling. That's another important difference that I noticed. I cannot put it to use just yet, but that's another important one. As you can see, the differences in peak power, if it is peak power indeed, because once again changing it doesn't seem to do anything for me, the differences in all of these go all the way through the engines, like all different physics and all different chassis and physics types have different peak power ratings, which is very, very interesting in my opinion right here. Yet changing it doesn't seem to introduce any change. It's very weird. Now, restricted plate engines, I must mention another thing. Right here in the power profile, we have RPM for max torque, I'm assuming at 42, and max power, if that is max power, I'm not sure. That's why I'm showing it at the moment, right now, at 9,000. However, our rev limiter is set below the max power. If it is max power, because it's only at 80, versus the 200 for the unrestricted, so the restricted plate really restricts the power, as you can see by the cylinder pressures, I'm assuming. But these restricted plate engines, all in general, comparing to other engines, will give us additional clues, together with chassis 0, which is very unique, so to say. It's very different from the rest of the chassis. Chassis 0. And the unused engine is really unused. I could not find it anywhere. So let's say these right here, the most used engines in the game. I'll mark them as orange for now. There you go. So comparing values, just looking at the broad metrics between all of them. This is a part 2. I kind of pointed out the most differences that I'd noticed. If you just look at the rest of them yourself, you could easily see what number variations are, but this is where I'm standing off at the moment. Next I will have to show you the thought of calculation and the physics changes that are introduced in the game and how it looks different in the game. But as far, I just wanted to show you the basic matrix layout for the engine that I'm working with. I'm gonna conclude the video here, and then probably I may need to make one more to kind of show you my approach to what I'm trying to do with this muscle car mod. Thank you for watching the video, and I'll get back to you as soon as I can.